Hello, everyone. I'm Chris Chinnock. I'm the Executive Director of the 8K Association, and welcome to our webcast for this evening. Actually, it's not a webcast, it's a meeting, isn't it? So I've just got a few slides I want to run through here, and then we'll bring in our speakers. There's a pre-recorded presentations that will run in this Zoom meeting, and then we'll bring those speakers back live for you to have some interaction with. I've got some questions for them as well. If you have some questions, please use the chat box. You should be able to see that in your interface. Wes Simpson's on here, and I will try to monitor that and present those questions to the panelists as we can. So here are our great speakers for this evening. Dan Duran, who's head of post-production and workflow at Red Digital Cinema. Aaron Kroger, Director of Product Strategy at Panavision. Ravi Velhal, Digital Media Standards Technology and Immersive Cinema and his colleague Ben Cope, who is the technical lead of Internet of Things Group, also at Intel.
And today we'll be going over the advantages of shooting high resolution, in particular 8K. If you're not familiar with Red, we're an ultra high def cinema camera manufacturer that has been used on such shows as Mindhunter, Stranger Things, Guardians of the Galaxy, and Planet Earth. So here's a brief history and evolution of Red cameras. Back in 2007, we released the Red 1 camera, which was one of the very first 4K digital cinema cameras out there. And that was way before 4K TVs were out there. So we would get very similar questions of, well, why shoot 4K if the deliverables are only 1080 or 2K for cinema? Well, as you can tell, 4K is a standard currently today, so you know 8K will be a standard in the future. In 2010, we released our 6K DSMC line. In 2015, we released our 8K cameras, which included our Helium, and that's our DSMC2 line. And DSMC stands for Digital Stills and Motion Camera. And then we have our modern cameras, which is the Ranger, which shoots our 8K Monstro large format sensor. So now I'm going to be covering why resolution is important to me as a filmmaker. First and foremost is image quality. What makes a good looking image? Resolution is always going to be part of that equation. You're also going to have bit depth, dynamic range, noise floor, color science. You know, it's a big equation. And if you remove one of those, you're not going to get that amazing image quality you would expect from a cinema camera. Next, I'm going to go into the flexibility of high resolution and what you can do with post and visual effects. And then finally, I'm going to go into future proofing and why it's important to capture high quality, high resolution images. So let's take a quick look at what a 2K HD image is compared to 8K. As you can see, the higher resolution you go, the more information and detail you will have. Another great way of understanding resolution and its benefits is converting it into megapixels, similar to a DSLR. So a 1080p file would be about 2 megapixels. A 4K HD file is about 8 megapixels. And you're going to see that 8K file is going to be about 35 megapixels. So that's a lot of information and detail you're capturing per frame. Next is one of my favorite topics, and that's super sampling. Just because you shot an 8K doesn't always mean you have to finish an 8K. So let's take a quick look at an example. On the right, you're going to see a 4K deliverable that has been downsampled from an 8K source file. At the top left, you'll see a 2K file that has been upscaled to 4K. In the middle, you'll see 4K that has been delivered at 4K. And then at the bottom left, you'll see an 8K file that's been downsampled to the 4K image. As you can tell, the 8K downsample is going to give you the smoothest, cleanest looking image. And the same goes for noise floor. Here's an example of a 1080 shot that was captured at 1080. And here's the same thing of an 8K downsample at 1080. You can really see how it cleans up that noise. Another advantage of shooting that ultra high def 8K image is you get a bigger canvas to work with. So as you can see here, the original source file was that 8K Komodo Dragon shot. And then on the right, you can see the final crop version. Because you have all that extra working space and look around space, you're able to pan and scan and grab whatever you want in the frame to really get the shot you're looking for. Another great use case for shooting ultra high resolution and oversampling is for stabilization. If you ever stabilize a shot, it's always going to have to zoom in a certain percentage. So if you oversample, you never have to worry about cropping heads or losing any part of the image you would want to keep. Another advantage of shooting 8K is you have the ability to pull individual frames from the motion clip. As you remember, an 8K resolution file is a 35 megapixel image, which is more than enough information to be used for stills for magazines, covers, or whatever the marketing campaigns need. Another topic I wanted to cover is future-proofing and why that should really matter to everyone. One of my favorite examples of this is a show you should hopefully know, and that's I Love Lucy. I Love Lucy used to be shot at Desilu Studios in Hollywood, which is now Red Studios. Well, back in the 50s, almost every show was shot on kinescope because that was good enough for the time. While Lucille Ball and Desi Arnaz wanted to shoot the highest quality possible and decided to shoot on 35mm. Because they shot on 35mm, her vision lasted the longest and is the most popular 1950 show today. Also because of the quality, whenever a new format came out, they were able to create a new deliverable. So you had VHS, DVD, Laserdisc, Blu-ray, and so on. A more modern example of this is one of my favorite films shot on the Red One back in 2009 called District 9, which actually just released a 4K HDR version of it a few weeks ago. One of the last topics I'd like to cover is how high resolution really helps in the visual effects world. We could have taken a look at blue or green screen footage, but I really think taking a look at Mindhunter shows how high resolution can still keep that natural looking image, yet still give all the benefits for a VFX artist. One thing with VFX is the better image you have from the beginning, the easier it is to work with. It's always going to be easier to add grain than to remove it, or to blow out the highlights than to recover it. So the more information you can give in the image to an artist, the better it will be. The last thing I wanted to cover is data. You're probably thinking that 8K RAW files must take up a ton of storage space. Well, it's not true. Our 8K Redcode RAW file codec is extremely efficient and very small. On average, our 8K file is usually smaller than a 4K ProRes file, yet it's 4 times the resolution and you have full RAW control. Well, I hope that covered the benefits of high resolution from a capture perspective. I just wanted to thank the 8K Association and SMPTE for having me. Thanks.
Hello everybody, my name is Aaron Kroger and I am the Director of Product Strategy at Panavision. And today we're going to be talking about choosing 8K for cinema and television. So when we talk about creatives choosing 8K and we start bringing this concept up, I think one of the first things that comes up is a lot of misconceptions. And I kind of want to spend a little time talking about what those are and then dispelling them a bit. So one of the biggest things that we hear is that why would I shoot 8K when I only have a 1080 TV at home, or so many of my viewers are watching this on a lower resolution screen. But again, there's a lot of importance to being able to capture larger and future-proofing your image. And then another misconception, which I'd say is one of the greatest misconceptions, is this correlation between resolution and sharpness, and people thinking that higher resolution is inherently sharper. And lastly, if people can get over these other humps of, exceeding display technology and sharpness, that even if I am okay with that the workflow is just unmanageable, whether it's the processing time and or the data rates just being unmanageable to deal with. So when we talk about dispelling a few of these, let's talk about exceeding the display technology and this argument that consumers aren't looking at 8K, so why would I capture 8K? And like I said, obviously today we do have 8K display technology and it is becoming more available, but the other thing is just it's really important when we let creatives know that talk about future proofing, and even though today it may not matter to shoot 8K, in the future it might. And so, what I love to do is look back at a little history lesson. And so if we look at 90s sitcoms, and at the time they were being broadcast over the air, standard definition. So we took Home Improvement and Friends. Obviously slightly different shows, but again, similar looks. And at the time, you'd probably say that there was not a large discrepancy between the looks of these two shows. Home Improvement was shot on tape, standard definition tape, but Friends was shot on 35mm film. So again, at the time, not a great difference in the image, but because we live in an era with OTT and all of this content on demand, all of the footage and projects that we've shot in the past and everything going forward has so much more life than it ever did. It's not just airing on one night and then maybe get rerun, maybe get syndicated. So now if we go back on these old shows and we look, Home Improvement is stuck in standard definition because that's what it was and it was acceptable for the time, but as technology advanced, that show was then stuck in that and limited to it, where Friends was exceeding the distribution quality at the time by shooting film. We can now go back and we have 4K Blu-rays of it, we have 4K, you can even do HDR. So again, now when you look at these two shows today, you can see a big difference. So I think it's really important for creatives to be thinking ahead and intending their footage and their shows to live on forever, and especially, like I said, in this era of OTT, we're on demand and much more evergreen content than before. I think the other big, the biggest misconception is this idea that 8K is too sharp, and there's this assumption that there's a direct correlation between resolution and sharpness. And there may be, there is obviously some element to it, but not directly and not in the way that people are thinking. Now, when we talk about digital capture, we are limited to polygons and we are capturing all of these organic shapes and flowing lines, but in a digital sensor, in any form of digital capture, we're capturing squares. So if actually we have less resolution, we have less smooth lines. So, looking at these circles here, again, more resolution will actually give us a smoother image. Still photography has realized this long ago and has used high resolution for many years now, and they're doing these portraits up close, all of this stuff, and we see that there's not necessarily this inherent sharpness, and that the capture resolution can be independent of if an image is sharp or not. Now, when we talk about workflow, the thing that can be perceived as being cumbersome is this idea of we're on a show, we're shooting 3 hours a day for 100 days. So we have all of this footage and we have to take this 8K raw file and we have to run every frame through our dailies process to get into editorial to be viewed before we get onto our online. So now we are seeing a lot of advancements in technology to make this traditional pipeline be just as fast as a lower resolution pipeline was in the past, but we also have even newer technologies that we can implement with proxy workflows. Now, the idea of a proxy workflow is while we're capturing our 8K high resolution file, we can also capture a lower resolution, a 2K or a 4K RGB file that can then go into our dailies process. So now when we take our project and we're running every frame through the dailies, we're just running through with 2K or 4K, and this is incredibly fast. And even those advancements in technology that are making 8K completely acceptable in a traditional pipeline, those advantages are still applied to our 2K or 4K, making them even faster. And now when we go to our online conform and our color correction, we are just dealing with the 22 minutes or the hour and a half of the movie, just the final select frames. And that's all we have to deal with the 8K. And so again, this just really makes the idea of shooting 8K much more manageable, and really was one of the big things when we went to develop our DXL program. We knew that was kind of, workflow was one of the big things, because also when we came out with the original DXL, which was over 4 years ago, this concept of 8K was even more foreign than it is today. And again, a lot of these misconceptions, we really had to dispel, and we had to make sure that we were addressing them within the camera. So for those of you that aren't familiar, the Panavision DXL2, a little overview. This is Panavision's large format 8K cinema camera. So this was a camera that was specifically built for the cinema and television industry, or kind of very specific sector. So we utilize Red's Monstro sensor, which is giving us 16-bit color depth. We're able to capture 16 stops of dynamic range. We can shoot 8K up to the full frame, up to 60 frames per second. And all of this is wrapped in a lightweight 10-pound body. Now, in terms of workflow, like I mentioned, this proxy workflow is something that was implemented in the DXL. And another thing that makes this 8K workflow much more manageable is that we are utilizing the R3D codec, which allows us to capture 8K images, raw images, at 1 terabyte an hour, which is really important for not only the process speed, but now we have a file and we're not getting swamped with hard drives and archive costs. And then obviously Panavision being a leader in the motion picture industry for camera accessories and accessorizing things. The whole camera is built around this modular design. And that's both for electronics, expanding functionality of the camera, but also just for the accessories and making a really user-friendly camera for the film industry specifically. So when we were starting down this path, we knew that we wanted a high resolution, but we also knew that we wanted to go larger. So when we looked at cameras on the market, when we were beginning to develop, the Super 35 was the standard sensor size for digital capture, but we knew we wanted to go bigger. So we actually went with a VistaVision size sensor, giving us a much larger capture area, which gives us a lot of benefits, not only for resolution. Now we're capturing a full 8K, it's a full 8K sensor, and then we're also capturing a much larger magnification. So this is actually 1.7 times larger than Super 35. And what was really interesting about this, and when we pair this with the high resolution, we got this new selection of optics. And by really new selection, a lot of it was actually old. Because we increased the sensor size, it became much more in line with our vintage Panavision 65 lenses. So we had our 65mm film cameras from many years ago, and we have an inventory of lenses that were created specifically for them, for that larger capture area. And what was really interesting about that is it made us realize that these legacy lenses and these vintage designs, when paired with high resolution, really gave us some unique options and really amazing images. So I want to talk a little bit more about that, and then this goes to dispel that, like, what is resolution, the sharpness, or not. And so this was shot on DXL. Both of these images were shot at 8K, we can see, but obviously there is an inherent difference in the sharpness. So again, same camera, same resolution, but we have a very different sharpness. And that comes down to lenses, which is the biggest factor when we talk about what creates softness or what creates sharpness. So if we look at our Primo 70, this is a very modern lens, and again, all lenses have their unique looks and their unique spots that are, what market segments are optimized for. But then if we take a look at our H series lens, which again, this is another large format, this is a true vintage lens. This was from the archives of Panavision's inventory and updated with modern mechanics. But we can see there's a very large difference in the sharpness. And when we talk about why that is, that's because modern lenses were really designed to be perfect. And it coincided with the digital era, this lens trend of creating perfect lenses. So we have all these different correcting elements. We have A-spheres and just different element designs where you can see here, we're actually able to get all of the rays of light to converge right exactly in the same spot. And again, as far as math is concerned, this is a perfect lens. And if we look at what an aberration would come through, we have this perfect tight cluster. All of the rays of light are converging in one spot. Now with an older lens or a less corrected lens, we can get our rays to come in closer and be, a bit sharper by stopping down, which narrows down the amount of rays coming in. And again, we have a little sharper image. But if we look at a vintage lens, again, without this correction, or not even a vintage lens, but a lens that isn't specifically correcting for spherical aberration, we get a less precise, and we get this scattering of light rays, which gives us that more organic and less sharp feel. So if we look at some projects that were captured in 8K that are definitely not sharp, these are just a couple examples that I randomly pulled of movies that were shot in full 8K resolution on the Panavision DXL, but they definitely have that vintage look. They have that soft look and that glow, again, because they were captured with lenses that were not as high of resolution, not as high a MTF, and had a different amount of spherical aberration and character to create a softer look. Now, I want to talk a little bit more about how those aberrations are captured and where really the magic of high resolution paired with vintage lenses comes into play. So if we take a look at a 8K sensor versus a 4K sensor with a larger pixel, so if we're looking at the same sensor size but with a lower resolution, and we take one of those aberrations and we go ahead and plot this on our sensor, we can see on the high resolution sensor, we're actually covering 6 pixels, which in a Bayer pattern sensor, which most all sensors today are, this gives us full color value for that aberration. As opposed to on the right, when we take a look at a larger pixel, an aberration may only cover 2 pixels. Now the problem with this is that when we go and we actually interpolate this footage, we go debayer this and play this footage out onto a monitor, we actually can get different colors. So because our higher resolution actually contained a red pixel as well as green and blue, we can see the color of our aberration is much more truer to what it actually was. We can see it has this skin tone hue to it, in addition to a little bit of blues into it, where the lower resolution was actually coming up falsely with just basically a pure green and blue because that red information was missing due to the lower resolution. Now, I wanted to show this in a real world example because obviously this, that's kind of a theoretical chart method, but this was a test that we were shooting unrelated to this, and we came across this firsthand and in the real world, and we thought it was pretty interesting, and I really liked this example. So we were shooting 8K and 2K with 2 different cameras, and one, again, a smaller pixel and larger pixel. And if we take a look and we zoom in, we noticed this when we were going through the footage, that the lower resolution actually had these weird interpolations creating different colors in the eye light. Now this scene, again, shot at the same time. This was shot with a single light source being the same color as her key, where we can see in the high resolution 8K, we are getting an accurate white rendition of that light in her eye, where in the 2K with the larger pixel, we're actually seeing a false color. So we're actually getting a yellow and a blue. Again, because of the fact that those rays of light were not being able to hit all of the same color, being able to hit all of the colored pixels to create a true correct image. Now, one of the things, as we say, we're zooming in and we're pixel peeping there, but all of these concepts are important, and we were able to see that error even on a smaller screen. And when we talk about this concept of smoothness and these, how do we create smoothness versus sharpness and all of the tenets of large format, it's really important to remember that all of these concepts apply to all display mediums. And yes, we think that display technology is going to continue to advance, but it's important that even for today, capturing the largest available palette and the tenets that happen with capturing with that large palette scale down to smaller screen sizes and the resolution. So you're really creating the best possible image by capturing the largest possible image. And I think the best example is if we take a look at some images, we can see that all these images here, this is just a 1080 keynote that we're looking at, and you're looking at this through a stream, but we can still tell that these were high quality images that were captured in large format and high resolution. They have the tenets of a quality image. And we know this is true because we look at this content every day on our social media, on our phones. So again, we can tell the difference between a high quality capture, a high resolution capture, a large format capture, even on a tiny little low resolution phone screen. And then as we scale that up to larger consumer screens and theatrical, the ability to notice the difference is even greater. So I think it's really important that we continue to capture the largest possible palette, the largest possible resolution, and we just continue to create better content, and we make sure we future-proof it for all of the generations to come with this evergreen content that we are continuing to create. So I want to thank everybody, and my contact is here, and if you have any questions, please feel free to reach out. Thank you.
Hi, my name is Ben Coe. I'm from the Internet of Things group at Intel, and today I'm going to discuss some of Intel's chip-level technology enabling 8K solutions. My job today is applying Intel's product portfolio for video in the IoT space, but I have a background in working for a company called Altera, who was acquired by Intel in 2015, selling FPGAs into the broadcast and Pro AV space. I'll try and bring both perspectives today. It's actually quite interesting to see in the IoT space how there's production-like use cases being deployed across markets. So for example, in the education market in China, schools are setting up a mini production environment in their classrooms to live stream the content for equity of teaching. Before I get started, I wanted to thank the 8K Association and SMPTE for inviting our participation today. And Intel's happy to be a member of both SMPTE and the 8K Association. So first, let's take a look at Intel's general role in the production environment. So starting with our Fpga technology, these are used right from the cameras in ISP processing and interfacing through to switch equipment, and then even virtualized accelerators in the cloud. Intel-based servers are used either in the public or private cloud on-premise for high data rate processing. The content processing types we've seen have evolved. So from traditional media processing, we're now seeing media analytics, immersive media, and interactive media. Good example of the use of analytics is to inform codec algorithms, as well as auto-archiving video. Intel Sports TrueView technology is a good example of immersive experiences, and this puts the fan virtually in the playing field. Example deployments are at the Arsenal, Liverpool, and Manchester City football stadiums here in the UK. Interactive application examples include cloud gaming, and it's interesting to think about how cloud gaming becomes just another media type in production. The Open Visual Cloud software provides building blocks and pipelines for cost-effective innovation in these areas. I think the key takeaway I'd like you to take from this slide is that Intel technology is present from glass to glass in the environment. So next, we're going to take a general look at Intel's processor technology. I borrowed this taxonomy here that was presented at the Intel Architecture Day presentation in September this year. More slides will be used on this presentation later. This classifies our processor types into 4 types. So first, scalar, which is perhaps what you know Intel best for in raw compute performance, for example, in the Xeon scalable processors. An example leverage of this is using the AVX512 instructions to bring high quality video transcode and streaming. Next is vector, and at the Architecture Day they talked a lot about GPU innovation, and we'll come more onto the XC architecture later. And this is very much whether integrated or discrete, use cases such as rendering and gaming that we're familiar with. On the matrix type, we have, for example, VNNI instruction set in the Xeon SP or Tiger Lake processor. We'll talk more about Tiger Lake later. And also discrete AI targeted products such as the Movidius portfolio. All these help to drive efficient inference implementation for the analytics use cases we described before. And completing the mix is spatial compute type. FPGAs are a really good example of this, where they provide low latency, high bandwidth inline video processing and I/O. Good example of the use of our FPGAs was in early UHD implementations. We did a press release with Ari in 2014, talked about the use in the Amira camera there with the Stratix 5 FPGA. As well as the processor components, we can't forget the platform components such as Optime memory and Smart NIC technology, and Smart NICs with FPGAs providing compute close to that network interface. It's very interesting as data rates go up. So the takeaway here is with ever evolving workloads, for example, analytics, immersive media, and interactive experiences, it's really important to have a heterogeneous mix of architecture types for efficient implementation. Next, we're going to zoom in on some of the Intel technologies and technologies that were mentioned within the recent State of 8K ecosystem report from the 8K Association. We're going to first look at the FPGA. We'll then look more at the Intel Iris Xe graphics architecture, and then finish up by looking at the Intel 11th Gen core, which is codenamed Tiger Lake. So first, looking at FPGAs, and for the purpose of this slide, we're going to focus more on the embedded use cases of the Intel FPGA versus cloud acceleration. To enable video implementations, provide a portfolio of in-house and partner IP solutions, such as 12 gig SDI, SMPTE 2110 support, TCO mezzanine compression, and typical processor functions such as scalars, the interlacers, and obviously most recently adding deep learning IP. For 8K implementation and processing, actually the foundational architecture that we use today was first demonstrated and presented to SMPTE in 2013, where we showed how to enable early 4K products. The parallelism here, or the challenge here, if I may, is the need for parallelism to address the scenario where the data rate of video is exceeding the achievable clock rate in FPGAs and exceeding what will be achievable in the next generation step as well. So today, this same architecture enables our video IP portfolio to support 8K and prepare for resolutions beyond. And there's a nice video on the website linked at the end, which gives an introduction how to do this. The latest FPGA technologies include the Agilex family, which provides 2 times the video pipeline performance with the HyperFlex architecture. This is really important to minimize the amount of parallelism you need to do, particularly when you go to resolutions like 8K. So the takeaway here is how the scalar processor type with the programmability of FPGA is really important in bringing latest and newest video standards to market early. So next we're going to look at the XE architecture. And it's important to realize when we talk about graphics architecture here, we're really looking at the graphics, media, and display capability. So the graphics are starting with that. The XE has up to 96 execution units, which for perspective is 1.5 times the number which were in the prior generation Ice Lake, which was up to 64. This provides a great level of graphics computation capability. From the media perspective, we have 2 of the VD box units of compute, which enable 8K 60 playback. And on the display side, 8K support through DisplayPort 1.4 and HDMI 2.1. The video pipeline supports up to 12-bit with BT 2020 color format, which means you can do HDR10 and Dolby Vision formats. This is the first time we have AV1 decode support in the hardware as well. So that's just some highlights from the XE architecture. This is realized first across three products, which we list on the right-hand side. The Tiger Lake 11th Gen core, which we'll come on to later, you can that can be found in the Intel Evo platform-branded laptops on the client side. And at launch, one of the key things that was shown in the launch videos was this is really bringing discrete graphics level performance to integrated graphics for gaming. And more on this next. The client graphics part codenamed DG1 was announced at CES, and also a server graphics part codenamed SG1. And here I'd just like to reference a blog by Lynn Comp, who's the general manager of the visual infrastructure division at Intel, referring to high density media streaming and transcode, as well as cloud gaming as example uses for this. So the key takeaway here is Intel's latest GPU with integrated media and display provide increased bandwidth of processing and I/O, which is important for preparing for 8K and other associated video performance improvements. So now we'll look at the 11th Gen core processor. So first off, everything we mentioned before on the XE architecture comes within this 11th Gen core, as we mentioned on the previous foil. It's also interesting to note that this product is also on the IoTG, will be on the IoTG roadmap as announced at the Intel Industrial Summit recently. And this is important for enabling some of those sort of IoT lifetime support and use cases. But also with some IoT targeted features such as focus on time and implementations like 1588 support, which is obviously quite interesting in a networked IP and synchronization world. Enhancements on the I/O include integrated Thunderbolt 4 and integrated Type-C. It's kind of interesting for attaching peripherals with up to 40 gigabits a second bandwidth support on each Thunderbolt 4 interface. There's also PCIe Gen 4 support direct to the CPU die. which traditionally the PCIe would come through the chipset, we've also referred to as the PCH. This is direct to the CPU, which has the advantage of providing high bandwidth memory access and low latency, really good for helping improve application performance. And then finally, we mentioned early on about AI capability, and really Tiger Lake shows a lot of AI and innovation supporting that from the CPU side with the VNNI instruction set, the GPU with FP16 and Intake support, and also for audio, the GNA 2.0 IP in that, and more not mentioned here. And I think I'd like to close on this slide with how Tiger Lake's referred to in industrial summit presentations, that really the processor here has an enhanced support for IoT and brings CPU, GPU, and AI capability, which really speaks back to that heterogeneity we talked about at the start of the presentation. So with that, I'll leave you with some further reading that can be found from the links on this file, and thank you for your attention.
Okay, great. Thank you very much, all my speakers. You did a great job, pre-recorded anyway. Let's see, I'd like to start with a few questions. Actually, I wanted to focus on the talks that Dan and Aaron gave to start with. Dan and Aaron, you talked a lot about the benefits of 8K, which is really good. But I kind of wonder how many of the key creatives in the production community, in the content creation community, as well as the decision makers, how many of those guys really get these benefits at this point?
I think it's still fairly new. A lot of producers, execs, directors, cinematographers, they're all still in their comfort zone. They like doing what they do and they don't really want to change. So what I do see is when a cinematographer takes out a camera and starts using high resolution, like the 8K Monstro, they get to see the benefits to the entire pipeline. They realize, what, it's not a lot of data. They realize, oh, it's not about sharpness, it's about detail and flexibility in post. So it's really, what I see is once people start using it and understanding the benefits and the concepts, that's when things will start changing and they'll start understanding.
Yeah, and I think, definitely agree with what Dan's saying. And I think there are definitely a fair amount of people that are capturing 8K, but even to some extent that some people don't even realize they are, in terms of depending on where they're at within the production pipeline. But the beauty is, both Dan and I spoke about it, this concept of future proofing and how technology is going to continue to advance, and by capturing the larger palette, is really important. And so I think, although there definitely are people taking advantage of it for its direct uses today, I think majority is just capturing that larger palette and having that available.
So if a large part of the community still doesn't understand these benefits, what do we need to do to educate them?
I mean, I think it's a lot of, it's just, it's events like this. It's just continuing to talk with the community. And I think, when we talk about specifically on the cinema side, we have different guilds and organizations, which I know both Panavision and Red are, members and participate in, but it's getting those kind of industry leaders through the ASCs and, these cinematography guilds to really start realizing the advantages and then pushing for it. And then, like I said, a lot of it really was a core of my presentation, was just dispelling, because with the advancements of technology and the chipsets and the computing power that is available today, workflow is certainly not 8K today is easier than 4K was just a few years ago.
Well, I mean, that's a good point. And this is kind of something we've talked about quite a bit, is that 8K today is very much like what 4K was like 6-7 years ago or so. But I think, I know Dan has talked about this before and thinks maybe the barriers are even lower to adoption for 8K this cycle. What do you guys think about that?
Yeah, no, I do think, yeah, I think it's getting faster. I think usually the capture end, right, in 2007, there's 4K cameras, and it took till, what, 5 years later to get an affordable 4K TV. I think 8K is a little bit faster with, I think a Samsung 8K TV you can buy for like $2,000, maybe two to 3,000. That's pretty crazy. The price point is dropping, and once you see the price point dropping for the hardware end, we're going to see a lot more people trying to use the technology and take advantage of it.
Indeed. Aaron, you want to, any comments on that?
Yeah, I mean, I definitely think, yeah, in terms of achieving it, like I said, it's the fact that displays are so readily available and you can go out and buy it. But then I think, the other big thing when we talk about adoption and how it's A, been easier, and B, how it's going to come faster is the changes in distribution methods. And previously with 4K and at the very beginning when it was coming out, it was most of our distribution was over the air, and that was, there was physical hardware transmission that really had limitations, and the infrastructure changes to increase that were so much greater than today in an OTT and in a broadband solution where we can just upload a larger file, do a firmware update on a device, and all of a sudden it can now, accept this higher resolution, display this higher resolution. So I think that also is one of the biggest factors in how the adoption will be so much faster than even 4K was.
Okay. And I want to bring in Ben and Ravi because one of the we just did a full report on the kind of state of the 8K ecosystem here, and certainly one of the key findings we found, and it was partly from feedback from folks like you guys in the infrastructure here, is that the 8K workflows are basically the same as 4K, but you need more storage, you need more bandwidth, you need more processing power. So first of all, do you agree with that statement? Maybe Ben, you want to jump in on that one? Or Ravi?
I think yes, yeah, in terms of number of pixels. So I think, one of the things that I mentioned in my presentation is how the processor technologies sort of evolving. So as well as just, I guess, increase in clock rate performance or increase in raw performance, but how you can think of improving sort of laterally as well in terms of the different types of processing. And we referred to those 4 architecture types. So things like the AVX512 instruction set, which you don't necessarily need to know what these acronyms are, but really just having, I guess, increasing the breadth of capabilities and be able to address the different workloads that are coming in with AI and more optimal codec implementations. And maybe I'll pass to Ravi for some specific examples.
Yeah. So I just want to be a little bit philosophical here because it's a knowing SMPTE and did a tremendous job over the ages, like to bring the technology and storytelling together. So Chris and my fellow participant, just look at where industry is right now, right from when Lumiere brothers started during the first, when there was no audio, and right from like now we are making movies in 8K or even like in a beyond format. So format goes through those transition, and there is like an 8 to 10 years life cycle, as you know. I've been at Intel for the last 23 years, but Intel has experience working in this area for last 25 to 30 years, I would say, where we took it pretty much like from predates to standard definition all the way to like 4K, 8K, and every format in between. So if you build it, they will come. And right now, definitely there is a growing need and growing appetite to bring more higher quality resolution together on making movie or even like a broadcast side, which we can touch base. But if you look at right now, we are well familiar with the lights, camera, action. But what is happening right now, it's transforming the industry from lights instead of camera, or with camera, lights, camera, compute, and action. So when you talk about like a compute, we are dealing with a lot of those parameters all together. So you name it from like in a format. It's not just about like an 8K just because of the resolution side. We need to discuss and talk about like it's a more pixel, better pixel, and faster pixel. All three things combined. If you have any cinematic shot, mostly like we cinematic work gets done in 24 frames per second. But if you look at like, billions half-time walk where frame rate has been increased. So we are kind of like pushing the envelope and the boundaries. And here our appeal to working with the content creators and the service industry and tech industry together, how we can get the ball rolling. And Chris, happy to give some example, but yeah, let's wait for more questions.
Okay. It's important to note that Intel is on this panel because, as Ben noted in his presentation, Intel has its fingers throughout this entire production pipeline from glass to glass. So that, and it's a lot of this technology that's going to be enabling this next generation of compute and resolution and better pixels, as you say. And I do agree, it is better pixels. And that's kind of one thing that maybe gets lost in the discussion about 8K. Everyone talks about it's more pixels. Well, it's always high dynamic range pixels what we're talking about here. And we kind of forget about that sometimes, I think.
Indeed.
Yeah. Let's see. From a workflow perspective, I don't know if any of you can make an estimate on this, but if you had to make an apples to apples comparison, if you're going to do capture, production, post-production on a low VFX kind of production, right? Independent filmmaker kind of production, and you're looking at doing it in capture in 2K, produce and finish in 4K versus 8K. Give me a feel for what the cost difference might be. Is it just, if you have an estimate on that?
Well, I think it, I would say with that, it's there's obviously a lot of variables involved, but one of them being, depending on the format, you might have similar data rates. So you may actually not have that much increased, such as an uncompressed 2K versus compressed raw format, such as R3D, which is offered in both of the Panavision DXL and in all of Red cameras. We're utilizing that raw wavelet compression. So depending on kind of your tolerance for compression, you can actually get your data rates down to be essentially the same. So, so storage, is essentially the same. And then I would say that really the other processing times are pretty negligible, because we're able to, most workflow processes we can have happen at 60 plus frames per second with today's technology. So this concept of getting through 2-3 hours of footage that you shot in the day is only going to take an hour and a half to render. So it's really negligible, I would say.
Yeah, and then also too, if you could, if you put your money into the computing, you don't have to ingest. You can link to it depending on how complex your deliverable is. Mm-hmm. And also too, you can probably reduce the number of cameras you use on a shoot. Because if you shoot at 8K, you can leave 1 or 2 cameras wide. And if you're delivering at 4 or 2K, you can push in, move, and do whatever you want without any degradation. So, depending on what you're delivering, 8K could end up, as the gentleman before me said, costing the same. And in some instances, you may be able to even reduce some of your post expenses by spending a little bit more on computing power up front.
Yeah, and maybe Dan could talk a little bit, because obviously, at Panavision, we are generally dealing with kind of, the really high end rental and whatnot. But from the Red side, especially with, they have 8K cameras at very obtainable price points, and have market segments that are, one-man band, single person, operations that are shooting and delivering 8K with no problem. So I don't know if you kind of had anything you wanted to add to that, Dan.
Yeah, no. I would say when 8K came out, I think we released our first 8K camera around 2015. At that point, the hardware wasn't quite there, so it was fairly expensive to transcode footage. You'd have to have multiple GPUs, playback for, files. It was much more expensive for SSDs. I don't think M2 cards were out quite yet. So everything was a lot more expensive. Today, you can get an off-the-shelf RTX graphics card that can play back and transcode 8K full res real time at a prosumer price. So it really isn't hard. And we see a lot of our users who are shooting 8K. They don't need the playback on an 8K monitor, right? You can debayer at a half quality, which is 4K, and that's good enough for viewing for a majority of people, or even a quarter, which is 2K, which is still fine. So just because you capture an 8K doesn't mean you have to edit and finish an 8K. You can still work in a 4K or 2K world, and at the very end, you transcode out to your 8K master if you want to. So I think this was more of a question 5 years ago. I wasn't gonna lie, it was fairly hard to work with 8K footage, transcode, playback, do the whole workflow. Now it's fairly easy because the hardware finally caught up.
So
yeah, if I may, I mean here, if you capture at high resolution, yes, enough computing power is available based on your budget. If you are working on file-based workflows, then we have machines that are relatively cheaper. You can have, especially for if you are a YouTuber, kind of an 8K setup provider. But if you are more into a corporate or the studios where you need a real-time live transcode, yes, we can do 60 frames per second live transcode using our Cascade CPUs, using a VNNI AI. So we have in one of the slide that Ben presented, heterogeneous prospects. So we have work from from CPU, GPU, AI, and Fpga, all things combined. And when we do that, it's a very complex system put together. But right now we are able to do 60 frames per second live encoding. So that is very remarkable. Think of this, if you're a sport broadcasters here or many sports event around the world that we have done. So it's based on, I guess, a point here is based on your budget. You can start shooting in a really high resolution. And right now technology has caught up right now, and you have tools available off the shelf. You can take it and start making part of your workflow, then just wait for your future.
Yeah, actually, let's talk about this transcode encode part a little bit here. I've seen companies talking about doing 8K 60 live and offline using CPU-based solutions, GPU-based solutions, and FPGA-based solutions. So all three are out in the wild there. What's Intel's take on the best architecture here?
Yeah, so again, there is no one shoe fits all, and it's also depending on budget, your requirement. But when we are talking here in a broadcast quality, live in transcode, encode and decode an entire pipeline, even in a transfer or 8K or 5 FPGA, there is a very little forgiveness here, especially a company like us. So some of your so the approach that I would like to take, I leverage a scalar as well as a matrix calculation, which is the AI, the VNNI AVX Python that he mentioned. Sorry about the technical mumbo jumbo here, but this is a part of combining your AI matrix calculations with the scalar. And the advantage of this particular architecture is it's a scalable because it's a general purpose computing that is available off the shelf, and you can build it and it can scale. So 112 core is what we currently right now using to do the 8K live 60 frames per second or 60 frames per second live encoding. And this is we are talking about less than 2 to 3 seconds of latency from a screen to screen. And when the encode happens, then you're talking about how we can take it, how we distribute it, whether it's a RTP or whether it's HLS or whether it's AWS. And we have done this publicly also last year at Interbe in Tokyo. We have shown this solution. So it's easily possible right now to take your 8K content and distribute throughout the world live. I mean, as you know, an NHK, there are a couple of satellite channels who does the 8K live in Japan as well, and more are coming up. So I guess there is a hungry and growing appetite, and that has a very little forgiveness when you're talking about processing that much data, from taking the 48 gigabits per second and just bringing out to 40 Mbps or 100 Mbps or 250 Mbps measuring signal. And that's where the approach that we are taking in terms of a scalable computing or leveraging our Xeon Scalable is a lot better. So you can attune to based on your requirement need, because a lot of time you need a variable bit rates and so on. So I guess it depends on what you need. And when it comes to file-based, it's nothing, you don't need anything like in a real time, and where you can take it, transcode it, but that's where like magic needs to happen. And the secret sauce is how you do the VFX, post, and the whole shebang. So I guess the requirement differs from the broadcast side and the cinema side. And we are approaching and tackling the both with by collaborating with a lot of industry partners here.
Okay. Ben, I wanted to shift gears a little bit, talk about, and Ravi too, talk about Tiger Lake a little bit. So that seems like a pretty powerful platform, especially I'm thinking for post-production, where they can do a lot of on-premises kinds of things with that fast interface, the Thunderbolt and the USB. What do you think about that?
Ben, you want me to take, or you want to take that question?
Sure, I can make a couple of comments and then maybe chip in. So I guess first, Chris, I think I would sort of clarify, I guess, compute distinction. So there's certainly a role for Xeon SP, as Ravi was just discussing, the scalable processor, and for Tiger Lake. So look at the scalable processor into the live production workflows, that sort of cloudification and the scalable nature that was being discussed. For Tiger Lake, I see sort of two folds of value for Tiger Lake. One of them is certainly in the client devices and like laptops, etc. And with the enhanced capabilities I talked about in the presentation, bringing enhanced performance for running production applications on there, as you would with prior generations. But also the other thing we can't lose sight of, and this is perhaps more closely related to sort of my IoT area today, is really about consumption of content. So with the 8K playback capability, getting readily available devices out there in the market that you kind of, if you're going to produce the content, you need to be able to consume it as well. So having media players that can sit behind digital signs and other sort of IoT products for the consumption side. So I'd look at it that way. I don't know, Ravi, if you'd add anything to that.
Yeah, so and again, like a Tiger Lake is a great processor we just announced, and think of this, it's a divine invention in terms of if you have portability. If you want to take it with you and take it to any production, you can easily take that based on the proxies and workflow, you can use it. But think of this, it's not just about the processor, it requires a lot of Intel technologies comes together. So one thing example here is the Thunderbolt, as well as like our faster storage, and then all the standards and all the security and all the cloud related processing. So we bring like all this holistic experience together to create the system and tackle the industry problem. So we are not just talking about like a particular processor, but that is our powerhouse. But in the same time, we bring all this radical innovation together on our platform to grow the ecosystem forward.
Now, it does have an integrated GPU as part of this platform, I believe, correct?
Yes, that's right. Yeah, the XC architecture talked about in the presentation. Yeah.
Okay. Is it powerful enough to do like 4K 120 gaming and 8K gaming, 60 gaming when that becomes available, or would you still want to have an external GPU card?
I have not tried actually on that one, since I'm working on mostly on the scalable side, but definitely like there are, I mean, Ben can answer, or we can take a look into it.
Yeah, so I can't answer specifically on 8K gaming. I know on some of the, if you watch some of the sort of launch material online, certainly, there's demonstrations showing how, in the laptop scenario, it's bringing that, discrete graphics level performance into integrated graphics, obviously in the presented benchmarks there. For those examples weren't in 8K, I would specify, but certainly, from the number of execution units within there, that's about up to 1.5x more than prior generations. So certainly a significant step up.
Okay, Dan and Aaron, have you had a chance to kind of look at these new generation of products and what they might do for you from Intel? Dan and Aaron, you're okay. There you
Am I muted? There we go. Yeah. No, I'm super excited. Right. The more processing power and what you can do on the back end, you know, the more ease of use, you know, our creatives can do, right? They don't have to worry about compute times, render times, you know, anything to save time is such a huge difference in the creatives world, right? Where it's now, I could be creative as I want without having to worry about anything. Makes a big difference.
Okay.
Yeah, and I think like you know, like I was saying in my presentation that there's obviously hurdles to 8K, and then a fallback that people have is like, oh well, sure, it's going to make a better image, but it's just too slow. And so obviously, yeah, all of these advancements, and every time that this computing process increases, again, whether you're doing the full 8K or like Dan was saying, whether you're just doing a quarter deep Bayer or you're doing a proxy workflow, you're still then getting those benefits. And yeah, and I think, you know, exceeding the, you know, getting obviously on the cinema side, getting above 24 frames is really the threshold. So that is the one nice thing, is it's a pretty low bar on the cinema side to exceed that. But then also because, you know, Intel is making these technologies for live broadcast as well, when we get these 60 frames, then all of a sudden we get 2.5 times real time. So now it feels really fast for the cinema side. So yeah, it's really great to see the advancements.
Let me just add a couple of examples here. 3 years back, there was a project that we started working with Warner Brothers, and Dunkirk, Save Every Breath. That's a project we did in virtual reality. We co-produced it with Microsoft and Dell. And back then we used 8 camera, and it was a motion lapse actually, like, and we were taking 20 shots to kind of fill 360 frames. So think of this, 8K multiplied by 20, almost like 156K to 160K of resolution per frame that we are processing. That time, and not having like an access to good, powerful enough processor, we used like our predecessor to current generation scalable processor. And we able to do it actually. I mean, we did it that time, and we able to bring it and then compress it the heck out of it. And those files are still available. So it's kind of like a go into like an endless zoom. And that is where we did not use any 360 camera, though it was like in a virtual reality project. We used a regular red camera, 8K, and we kind of like took a shot and able to stitch it. It was a nightmare, but that was well done, and it's available in market. Second example I'll give you, like in the last year, we co-produced Grease in volumetric at Intel Studio. And we had like, you know, more than 105 4K cameras as a part of our studio back then. And we captured more than 5 trillion pixels for that 3.5 minute song, You're the One I Want. So give it like in any scale and the data and the complexity, there are several solutions available right now that you can do it, but you always need to kind of like innovate and see what problem that you're solving underline. It's not just like, you know, we have a technology, so you can start using it, but you have a identifiable, like, and you have like a pretty good problem that you need solution. Yes, we absolutely have some track record in delivering something good, but we do this with a larger collaboration with the industry. We work with a lot of studios. We work with companies like Practical Magic and other projects that we have done, a lot of those virtual reality and immersive cinema project. So I guess there's no one shoe fits all, but that's where we collaborate and bring some creative minds across the industry to bring storytelling meets the technology.
I want to also make sure you in the audience are part of this meeting. If you have questions, please enter them in the chat box. I do see one here. Question to Dan. Red, is there any plans or arrangement to have live production module attached to the Red Helium?
Let me unmute myself. No, not that I know of. If it looks like it's because they want 8K live output, I'm assuming. Let me just read the question. Yeah, there isn't for the Helium or any modules attached that I know of. But yeah, that's something we're always looking into, is how do you get 8K, you know, signal directly out of camera. We have done in the past, and especially cameras. So that's something you're looking to do. You can always reach out to Red anytime or to me. But yeah, no, not with the Helium specifically.
Okay. Actually, Aaron had a question for you. You're a rental house. You talk to content creators all day long. So I'm sure they ask you, you know, 4K, 6K, 8K. How does that conversation go? And how many times is it steered to 8K? I'm just curious.
Yes. Well, it's, you know, there's it's interesting because we have a wide variety, because we have some people that are interested in the benefits, and we have projects that come in that are specifically visual effects heavy, and they know that they want to be able to do that framing and that reframing and stabilization and a lot of effects work, and that really drives to higher resolution. But then we also have people that are just looking to meet the demands, meet the spec requirements for these OTT groups, and really all studios. Even we're seeing the broadcast sides and the CBSs and whatnot, everyone's starting to kind of create standards so that they have that content that looks, so that the money that they're investing in this content will look good. But so generally the conversation starts based on, a lot of times it is like, do I need this? If they're not already looking into it. And then I think a lot of people realize that there are a lot of benefits, and as we go through it, it certainly opens up people's eyes, and then they are interested in it. And yeah.
Especially after you educate them all the benefits that you just went through in your presentation.
Yes, definitely.
Now, also kind of expanding on your point about the sharpness, even if you have an 8K camera, you could choose a legacy lens. In reality, it may look like a 4K image because it's kind of soft, for example. So the content creator may say, well, gee, I'm going to be using a legacy lens. Why do I need 8K? And your answer would be, well, you got the super sampling and the noise reduction and all that. Is that correct?
Definitely. Yeah, there's, again, because lenses really are what's controlling your sharpness, that then, now your resolution, you still get all the other benefits, even if you take that sharpness down. We definitely see it is very common for shows to be shooting extractions, which is, one of the things Dan was talking about, where, you're shooting a larger area, and then you might actually just be taking 7K or 6K out of the middle. So you can, which is something that David Fincher really kind of pioneered, and he's always taken advantage of high resolution and been a driver behind it for that reason. It's kind of interesting, most of his shows, almost every shot is stabilized, even tripod pans, even a lock off shot, because someone walked by and if you zoom in 8,000%, it jiggled a little bit, and so if you take a look at David Fincher's work, everything is just perfectly perfect. Wow. And that is due to high resolution capture. And it's just one of those things where also when filmmakers start to realize that you don't, when the boom dips into the shot, and you have that extra resolution to bump it down, all of a sudden it's like, okay, I didn't lose that take. I don't have to choose the worst performance. I can just reframe it because I have more resolution than my deliverable. So I can afford to lose, a K or two to punch in for whatever it is that you missed in the frame on the day, or when, the actor or actress missed their mark, or the camera operator just missed their mark. So it really kind of funny going full circle back into, does it cost more? It's like, well, there can be cost savings that you don't even really, directly realize.
Great point. Great point. So Dan, kind of, I think part of your job is working with people who own Red cameras and trying to help them solve their problems. So what are some of those problems? What's your day job like? You're muted.
Thank you. Yeah, when it comes down to it, it's really, understanding the benefits, lots of misconceptions, and really like everyone treats the camera differently. Usually the higher end shows with the bigger budgets, right? They can do whatever they want, right? They're happy they get the flexibility in post. Like Aaron said, David Fincher, he has a much bigger budget in his shows like Mindhunter and Mank and so on. So he gets a lot of flexibility. But the guys who don't, right? The independent guys, the lower end guys, they really take advantage of the technology, right? They're the guys who really go through and look at every button in the camera and say, well, how can I use this to save money or time, right?
Yep.
So, and they do that a lot with 8K. Like Aaron said, the great example is control of the image, right? You have a big canvas to work with. You have a lot of control within there. So say I don't have enough time to set up 2 cameras for interview. You can technically, zoom in on a shot a lot more because you have that extra resolution.
Yep.
The cameras also can do multiple things. They're pretty much computers nowadays, so they can create, proxy files at the same time as recording. So say you're a run and gun show, you need to go through and work off, a laptop that may not be able to handle any raw file whatsoever. So you can work off proxies, and then when you go to finish, you can reconform back to the raw file itself. So yeah, it's really funny. Like I would say that the lower budget guys really take advantage of the technology, find every single button and see what it can do, where the high-end guys understand the concepts, and they want to make sure they have as much flexibility, especially in post when working with files, and 8K will give them that in the resolution aspect, and gives them the control that they really need. So.
Interesting. I would have almost thought the opposite. There's actually a question in the chat here. It's for Dan and Aaron. Is there a quality/degradation in converting 8K RAW format to 8K YCBCR 420? That is, will the quality benefits of 8K be apparent in a video of that format?
Yeah, I mean, I definitely, there's still lots of benefits. Obviously, we've been talking about all this stabilization and all of this other things that resolution can provide to you. But even, again, just the, how the image, the characteristics. So part of it is the photo site size and how does that interact with your optics. And that will definitely play through. And, and I would definitely say that the best example is still photography, as to see, like, does higher resolution have a benefit even on a lower resolution screen? Is like, yeah, you can tell when someone took a photo on an iPhone on Instagram versus when they took it on their 100 megapixel Hasselblad.
Sure.
So, now to be perfectly honest, obviously, depending on how you're doing your scaling from 8K to say SD, you could with some poor scaling algorithms, you could potentially have some issues, but with modern day, all the options we have in software and everything should be really no reason that you shouldn't see all the benefits.
Yeah, and then same goes for most codecs, right? The more information you give the codec, the more efficient it is. Mm-hmm. So with our 8K red code codec. And our current 8K cameras, they're all wavelet based. So you're pretty much able to shoot the exact same resolution or exact same data rate as a 4K file compared to 8K file, but it's just more efficient, right? The image will look better. You'll have more detail, more information. So when you do go down to, another codec, it's gonna look great. And it really, really does help.
In the few minutes we have left, I want to talk a little bit about cloud services. So I think there's a clear trend, at least in some of the higher end, well, I guess it could be across the spectrum here, to move to cloud processing. The idea that your originals move into the cloud, that you could have cloud instances where you can run all of these applications in the cloud, that you're working potentially just with proxy files on local premises devices, and everyone can collaborate in the cloud, et cetera, et cetera. So do you see this vision coming true sooner than later? Dan, since you're up.
Yeah, no, it's definitely, one of the hot topics, right? Being able to work off the cloud, we see a lot of people out there who are using machines in the cloud, right? So you can rent a high powered VFX hardware machine or editorial machine, work off the footage on the cloud on that machine. And that really is an interesting topic. Just the amount of access you have and control of being able to just log in, use hardware through the cloud is very cool. And same for data and editorial, right? Able to have your footage up in the cloud. You do VFX pulls from a cloud service into whatever you need to go to a post facility. Having it there, having it render, having it do everything is really cool. And especially with the speed, of 5G and everything's coming out there, I'm probably going to see a lot more productions trying to get stuff on the cloud right away.
Yeah, and I think I definitely think it is definitely moving that direction. And I think one of the things that's been interesting is I would say that although we've actually had a lot of this technology for a long time, one of the biggest issues that I always run into because we're dealing with larger studio productions is just security. And obviously that was always used to be kind of the chief concern. And I think there's a couple things. Obviously, we're virtual now. Obviously this pandemic has created and forced us to move virtual and move things to be internet based, to be IP based. And the concept of sending video from set to other places is just kind of now a necessity because we can't have those number of people on sets. And so it's also just a bridge to moving to putting your own egg up there and everything. The other thing is now we have so many of the big players in the market are actually internet-based companies. So it's no longer just Warner Brothers. It's not just these brick and mortar studios. It's all these OTT groups that their foundation is to have their content on the internet. So it is much less frightening for them to and some of the groups even own the cloud. So it's like if it's not secure, then that's their fault. So I think that's also a big element that's helping to push that to happen, which is just going to make 8K more accessible and easier for everyone.
Ravi, what do you think?
Well, necessity is the mother of all inventions. So definitely this is it just not when. It's already going to happen, and there's a lot of companies and people are working on this kind of things. And think of this like previously when we were working on certain project, people has to ship this hard disk from India, do the post processing here and take it carry forward. So a lot of those things, and of course it's not trivial such as a HD or 2K. We are dealing with lots and lots of data and file size. So of course, like with advent of 5G, where we are driving that transformation at edge, cloud, and network, all three layers. So there is a lot of phenomenal innovation is also coming to market, and we are driving a lot of those areas in 5G. So when it comes, how fast you can do, and how we can cohesively manage the workflow. And like Aaron mentioned, one of the biggest concern is going to be there is a security of this, because we need to make sure who has the rights access. It doesn't get, because it's as much as putting your negative there. So Movie Labs also, there's a paper has been published, highly recommend on those cloud-based workflows and so on. So industry is working, but there needs to be some standardization needs to happen, and checks and balances in a place. But I guess pandemic has taught us how to get together and work. Otherwise, this conference also would have not happened. So I guess it's just a matter of when it's going to happen. And we are big believers in.
So what about the cost of moving all this to the cloud? Is it cost effective yet? And for who is it cost effective?
I mean, with my limited experience, it just depend on what you're trying to achieve. What's your budget? Because it's depend on even let's say right now I have 1 gigabits per second down and up link. So if I need to do in a real time live, I can do that. And that is if you need to get that bandwidth in US, it's available for $60. So the bandwidth is going to be the big cost. And then think of this, having this storage in a cloud. There's a lot of things you're offloading from your buying those hard disks and so on for your local processing. So I guess there is a price versus an expectation kind of trade-off that needs to be met. So I don't want to give you any specific number. One approach is better than the other, but it depends on what your requirements are.
Okay. We are, well, at our time. Let's see, Dennis, you put in one question here for Dan and Aaron. Have you taken any questions on repurposing monetization of 8K assets? So maybe Dan and Aaron, you can finish off with that if you want.
Yeah, we're seeing a lot of vendors now asking for 8K files. So, there's always guys like Adobe Stock and Getty Images, and, they want to separate themselves from other vendors out there. So 8K is what they're, we see a lot of asked for nowadays. So before it was, big 4K push, get 4K files, 4K ProRes, 4K RAW. Same thing's going for 8K. So I think the other side thing is you can pull stills. Like we went over, it's a 35 megapixel image, so that's definitely higher quality than what you would be getting with a 1080 or 4K image. So we're seeing both. But yeah, a lot of these stock photo companies, which is kind of cool, are asking for both now from 8K footage.
Okay, we are going to stop at this point here. Thank you, panelists, for your contributions. Thank you, audience, for attending.